Welcome. This will be our fourth example of general substitution method. This time we have the initial condition. So we'll take care of that later. So first find the general solution, then use the initial condition to find the specific solution. So let's start with the general solution. So I have it there. You might think this is exact and you can check it, it is not. You might think this will be separable, but it is not possible to separate x and y. And this is not linear. Okay, so let's do the substitution. So here you can substitute v equal to 3x plus y, or you can do the whole denominator. It's better to do the whole denominator, so let's do that. Okay, so I'm going to use the substitution v equal to 3x plus 2y plus 2. Let's do that. So the same way we did before, make sure you watch the previous 3 videos on general substitution. So I take the derivative of both sides with respect to x. And of course, the derivative of 2 is 0. So I have to solve for dy dx. So let's solve for dy dx. So let's subtract 3 from both sides. So I subtract 3 from both sides. And then I multiply by half to get rid of this 2, right? I multiply both sides by half. So that will be my dy dx. So my dy dx is this quantity here. So that goes in place of dy dx. Now here, of course, I know that this is v, but how about 3x plus 2y, right? So that comes from here. My 3x plus 2y is, of course, going to be equal to v minus 2, right? If I bring this 2 to the other side, because I need that. So this v minus 2 goes in place of 3x plus 2y. So let's do the substitution. So that's the left hand side, equal to v minus 2 on the top, and on the bottom is simply v, which I can rewrite as, if you distribute that, that's actually just 1 minus 2 over v. Perhaps I can leave it like this. Actually, don't do that, because this will be separable at the end of the day, I believe. So here, let's multiply both sides by 2. So if I multiply both sides by 2 to get rid of that 2, right? Okay, so this will cancel out. Okay, so I have, it's basically algebra. So I have dv dx minus 3 equal to, let me multiply this out. So I get 2v minus 4 over v. Let's add 3 to both sides. So I'm adding 3 to both sides. Let's combine this to one fraction. So I'm going to multiply the top and bottom. Remember, 3 is 3 over 1. So to combine, I have to make the denominator same. So you are going to multiply top and bottom by v, right? So let's do that. So the v is the common denominator. So I have 2v minus 4 plus 3v. So that will be, at the end, I get dv dx equal to 5v minus 4 over v. So let's move all the v to the other side. So in other words, I'm multiplying both sides by the inverse of that. So v over 5v minus 4, both sides. So what I have in this side is v over 5v minus 4 dv. In this side, just 1, but of course you have to move this dx. I multiply both sides by dx, so that will be dx here on this side. So now you take the integral of both sides. How you take the integral of the left? So there are several ways of doing it. You can use the long division of the polynomial, or you can try to use some trick here. So for example here, first of all, you can factor out. So you need that, you need that. So the different way of doing it. So one way, you can just multiply by 5 and then divide by 5, because you want to match that 5v. And then because you have a negative 4, you just put a negative 4 and plus 4. See, you're not changing anything, you're just rewriting this to so that you can simplify this. Okay. So what, and then if you continue, so I get 1 over 5. Okay. And then I can distribute, you can distribute this denominator under each one. It's a simple trick. You will get used to this type of trick as we go along. Or if you're confused, you can always go and do the long division, the long division of polynomial, which I'll not do this here. So you can divide this v by 5v minus 4, and you can continue that. You'll get the same answer. Okay, so here what I get is 1 plus 4 over 5v minus 4. Okay, so let's take the integral of this now. So the goal is to find the integral, right? So I'm going to put this 1 over 5 outside the integral. So let's do that. So 1 over 5 I copy. So let's distribute the integral so nobody get confused. I'm going to put this 4 outside the integral. So 4 is outside the integral, like that. Now there is a simple, instead of doing the substitution every time, it's a good idea to remember a few trick and formula. So in general, the integral of 1 over ax plus b dx is equal to 1 over a ln of ax plus b, like that. Of course, plus c, which we're avoiding. You just add c at the end of the day on one of the side. So here your a is actually 5. So if you use this formula, you avoid using the substitution and you save some time. It's okay to use this type of formula to quickly do your math. So the integral of 1 is v plus 4 over 5, because you have that 1 over 5. That's your 1 over a. ln of 5v minus 4. Don't forget the absolute value on the ln. Multiply out. So I get 1 over 5v plus 4 over 25 ln of 5v minus 4 equal to, now what I have on the other side, don't forget that's on the left hand side only. The right hand side is just the integral of 1 dx, which is just the x plus c. You just add c on one side. So on the right hand side, it's just x plus c. At the end of the day, you have to substitute back the v. So what is my v? My v is actually equal to 3x plus 2y plus 2. So let's substitute 3x plus 2y plus 2. So my v is equal to 3x plus 2y plus 2. Let's substitute this back. So that will be my implicit general solution. So that's the implicit general solution. But now we have initial condition. So let's look at the initial condition. My initial condition is y of -1 is -1. So let's do that. So now I have to substitute the initial condition, right? So, so let me actually insert a paper. Okay, so let's do that. So my initial condition is y of -1 is -1. So this means that when x is -1, y is -1. Or as a geometric point, the graph has to go through the point -1, -1. So let's do the algebra here. So I'm going to replace x by -1 and y by -1. So can we do that? Let's actually copy that in the next page. Let's continue. I'm going to replace x and y by -1. So let's do that. And it is possible that I make mistake when you substitute and doing the algebra in my head, but I'll try my best. So I'm replacing x by -1 and y by -1. Get that? Okay, so let's see what I get. So this will be -5 plus 2 or -3. So I get -3 over 5 when I multiply out, plus 4 over 25 ln. Let's see what I have inside ln. So this will be -5 plus 2. So that will be -3. And when I multiply with 5, that's -15, -4. Equal to -1 plus c. So at the end of the day, c is going to be some number. So this is going to be -3 over 5 plus 4 over 25 ln absolute value of, so that's -19, equal to -1 plus c. So if you solve for c, you add 1 to both sides, right? So you get 1 minus 3 over 5 plus 4 over 25 ln of 19. If I take the absolute value of -19, it's just 19. So at the end of the day is some number. And you can use a calculator to approximate that number. And that c, as in fact, will go in this place of c. So this c here, this one goes in place of here. And that's it. You copy everything here, except in place of c, you substitute this number. You can either substitute this in the exact form or you can use a calculator. It's your choice. That's it. Bye bye. Always remember you can do it. Thank you.